Okay, here we go. Boy, we are so near the end. You only got 2 more videos to watch of me, but I still miss you terribly. So we are doing what's known as the bell curve or the normal distribution right here. So starting out, a few little symbols I want you to know. So this is the mean. Mean is like your average. And also called that little funky little symbol here. It looks like a cursive M, but it's really not the symbol. It's called the mu, and I love saying that, the mu. Just remember, I like saying sphere. You know how weird I am. So mu is another one of my favorite math words to say. Over here, this symbol is sigma. It stands for standard deviation, which I'm going to talk about in a minute. And then this thing called the empirical rule, so I'm going to show you too. So when we talk about normal distribution, we're usually talking about a set of data like your IQ scores and your test scores. And when I give you guys a test, I usually like to see that, you know, are my tests legit? Or do they fall on this normal bell curve or normal distribution? So let's talk about this. So I gave you a sheet of paper. Hopefully you printed it. Hopefully you have a calculator handy dandy. And you need to fill this out because this is going to be important for you to have for your homework for the next 2 days. So on a normal distribution, inside here, in between the blue lines right here, 68% of the data, this would be like your C average, falls in between this part right here. This is your middle data. So that's 68% of your data. And then in between the pink lines, if I have the data here, and this would be your average, by the way, 68%, this would be like your C average. Most people have data fall here, and most people, their IQ is right in between here. So from the 2 pink lines, from here to here, this would be 95% from here to here. And then, so from the green lines, if we fall in between the green lines of our data, okay, from here to here, this is underneath the curve. So if our test scores fall anywhere in between here and here, this would be 99.7, sorry, percent of our data would fall between here and here, these 2 green lines. And then out here, if I went the whole bell curve, of course, that would be a full 100%. So everything underneath the bell curve adds up to 100%. So this is called the empirical rule. So the empirical rule, if I stand like this is your mean, this is your average right here, 0. And then you go from here to here, this is where most of your data lies, 68%. So most of your data lies in between 68%. And then you go to here, so that's 95%. And then 99.7, and then they go, the stats guy goes, just to here would be the rest of the data, that would be 100%. And he goes empirical rule, but I won't say that. Oh, I just did. Okay, so you go 0, 68, 95, 99.7, and then the rest of the curve would equal 100%. Okay, so you kind of need to know those numbers right here. Okay, so then, now I'm going to show you what standard deviation here is. So right here in the middle, this would be your mean or your average. And then so when I go to the right, this would be 1. That's called 1 positive standard deviation to the right. If I go here, this is 2 standard deviations to the right. And if I go 3, that's 3 standard deviations to the right. Like Albert Einstein, I think he was somewhere like 2 or 3 standard deviations to the right. I should know that, but I can't remember. He was close to 3 standard deviations to the right. His IQ, he was just that smart. So then, if you go to the left, this is -1 standard deviation. This is -2 and -3. So these are standard deviations. So you could put this little sigma symbol. Oh, I did it backwards. Of course, my dyslexia is falling in here. I did it backwards. Whatever. I'll do it backwards. I keep doing it backwards. So that's your little sigma, but I did it backwards. Okay, so if I said to you, what's 1 standard deviation? One standard deviation could be to the right or to the left of the mean. So if I say, gee, where did the data fall from one standard deviation from the mean? That's 68%. So 68% of the data is one standard deviation, because that could be right or left. If I say what's two standard deviations from the mean, that would be here. That's 95% of your data falls two standard deviations. Okay, so that's kind of the hard part. It does get easier. I'm just kind of explaining this is your data. Again, remember, this is like where most people's IQs are, right here in the middle. Right here in the middle. Okay, so now there is some numbers down here that changes, and this is why you need your other worksheet. So we're going to start filling this in, but I want to go to the bottom one, and hopefully you're filling this in. You can always pause. There is something real important you need to do with your percents. So remember how this is 68%? You need to start breaking that in half. So if I take 68% and I break it in half, this would be 34%, and this would be 34%, because I just divided it by 2. So 0, 68. Now I'm going to go, and I'm going to go to 95. Well, I know from the pink lines, this equals 95%. Well, I want to break this down here. So if I was going to break this down here, I would take, and I'll do the math over here to the side, 95 minus 68, and then I'm going to take that answer, which, what is that? 15 from 8 is 7, 8 from 6 is 2, is 27, and then I want to divide it equally by 2, and I'm going to get 13.5 and 13.5. Now think about it, if I add all that up, that still equals 95%. So you're going to want to know how to break these up even further. And then remember, so it's 0, 68, 95, 99.7. So now I need to find out what this is. So if I take 99.7 minus 95, and then divide that by 2, then these two little pieces over here are going to be 2.35. Of course, I forgot my percents. They don't fit in very good. So remember their percents, 5%. And then these little tails over here, so you have 99.7%. That leaves you 30, I'm going to talk money. So that's $99.70. How much do I have left over? 30 cents. So 30 cents divided by 2. So these little tails over here would be 0.15%. 0.15%. So you take your big percents and you need to break them down even further. You need to break them down even further. So I'm going to do that on the top one too. Remember, you can always pause, fill this in, because you really need to have this fill in before I start taking that worksheet and doing it with you. So let me bring this down, the first one, and I'm going to fill this in real quick up here. I'm just going to put 34. I'm not going to put the percents. Remember, it's a percent. 13.5. And then this is 2.35. And remember, this is 0.15. I'll draw a little arrow. So this is 2.35. And this one is 0.15. And honestly, if I'm doing the bell curve, any work with the bell curve, I don't even put in the 68, 95, 99.7. I just break it down into these numbers. That's how I leave it, those little numbers. Okay, so let's go to number one. Number one. Ooh, better kind of hurry. So number one says, what percent of the data is in the range between 110 and 130? Now I'm going to show you how easy this is. So between 100 and, oh, my bad. Number one, I need to break down the mean. The mean is 120 and the standard deviation is 10. So here's what you need to do to every circle. You look at the information. It says the mean is 120. So I'm going to put that here. And then it says the standard deviation is 10. So the standard deviation just means that as you're going up to the right 120, 10 standard deviation of 10. This would be 130, add 10, 140, add 10, 150. If you go to the left, you subtract 10. So this would be 110, this would be 100, and this would be 90. And there you go. So if we were taking your IQs, let's say, that's not right, let's a test average, this would be the average, and this would be to the right, and this would be to the left. Okay, so number one, it says, what percentage of the data is in the range of 110 to 130? Okay, so here's 110 to 130. That's the two blue lines. Well, right there, 68%. So the first answer for number A, letter A, is 68%. Then for B, it says, what percent of the data is between 90 and 110? So I go up here and I go, okay, here's 90 and here's 110. So between 90 and 110, I'm going to add 2.35 and 13.5. And when I add those two together, I get 15.85%. Okay, then for C. C says how many, it doesn't say percent, so this one's important, are within the limits between 100 and 150. So 100 and 150. So here's 100, here's 150. So I want you to watch how I do the math here. 100 to 150. So 150 is right here. So, well, actually, it's not going to be what I thought. So I'm just going to add all those up. So 13.5. Well, I know that's 68. Well, hold on. I know from here to here is 95. So all I got to do is add 95 plus the 2.35, or if you want to, just take your calculator and add them all up together. So when I add all this plus this, and I already did the math, you get 97.35%, but you're not done. 97.35%, because it says how many. It doesn't say what percent. So I have to go back and look at my data. It says we have a set of 1,000 values. So I have to take this and I have to multiply it by 1,000. So I have to go 1,000 times, don't forget to move the decimal 2 places to the left. So 0.9735. And that equals 973.5. If it says to round to the nearest whole number, round to the nearest whole number, but this one isn't specific. So if it says percent, like on A and B, you would be done. If it says how many, you have to multiply it by how many values you have. Okay, let's go to letter E. So letter E, I'm going to put over here. It says how many, again, values are greater than 140. Okay, well 140 is, where's 140? So 140, I'm going to add 2.35 plus 0.15 together. That gives me 2.50. So for letter E, I'm going to go 2.5%, and I have to multiply that by 1,000. So I need to move the decimal 2 places to the left. So that would be 0.025 times 1,000, and that would give me 25. And there's E. And then for F, oh, that was, whoa, that was D. My bad. Sorry. Then for letter E, which I'm running out of room, letter E says how many values are with 1 standard deviation from the mean. Now, good, this is a good one. 1 standard deviation from the mean is this one. 1 standard, so it's right and left. So it'd be 0.68 times 1,000, which is 680. And I have to do part 2 on another tape because I'm running out of time because I talk too much. Sorry.